All right, last video of the chapter, and it's a doozy. This is section 1.7, day 2 of solving absolute value equations, and today is the inequalities. We're going to have inequalities and absolute values in the same kind of statement. We got to find them solutions. All right, case 1 is going to look like this. But by the way, there's basically all the problems in this section break down into two different cases, case 1 and case 2. And if you can you notice the difference, there's going to be an absolute value of something here, and there's going to be a number over here. But the real difference is which way is the symbol pointing. Is it a less than symbol, or is it a greater than symbol? Case 1, let's take a look at that first. When it's the less than symbol, let's think about numbers that are going to be less than or equal to 3 when you take their absolute value. So for example, you can say that all of these numbers, like 0 is less than or equal to 3. 2 is less than or equal to 3. Even 3 is less than or equal to 3. Then you could also take these numbers over here, all the negative numbers, and take their absolute value, and their absolute value would still be less than or equal to 3. But the stuff on the outside, like what's the absolute value of negative 5? It's positive 5. And positive 5 is not less than or equal to 3. So same thing with 5 over here. You take its absolute value, and it's not going to be less than or equal to 3. So basically, we're talking about a shaded region in this area right here. And if you want to look at it on a number line, it looks like this. And you can see, because of the or equal to line that's right here, this is going to be solid and solid. But what I really want to talk about is case 1. Touch your thumbs together like this. That's case 1. Case 2 is going to be the other way around. But case 1 is going to be all the numbers in between this number and this number. In this case, negative 3 and positive 3. Even the decimals in between them, like 0.6 and negative 1.4. When you take their absolute value, it's going to be less than or equal to 3. So let's shade it in. If we wanted to solve this, then it's going to be similar. We're going to replace the absolute value of x with plus or minus x. Again, just like last section. So we start, instead of the absolute value of x, let's have plus or minus x is less than or equal to 3. And here's the positive version. You can see x is less than or equal to 3. And then here's the negative version over here. Negative x is less than or equal to 3. Well, to get rid of the negative, you have to multiply both sides by a negative number. And flip the symbol, and it turns into this. X is greater than or equal to negative 3. That's where this negative 3 comes from, and this positive 3 comes from. And if you wanted to, in case 1, you're actually able to rejoin. You don't really have to, but I think it's easier to write. You can rejoin these together. This statement turns into this part right here, and this statement turns into this part right here. So I like this statement because it shows you x is all the numbers in between negative 3 and 3, including the boundary points of negative 3 and 3. All right, let's take a look at case number 2. Same as case number 1, except we're going to flip the symbol. And we're noticing that a 0 does not work. You try and put a 0 in here, and it just doesn't work as a solution. The absolute value of 0 is still 0, and it's not greater than or equal to 3. But say 5 is, 10 is, 100 is, even negative 100, you take its absolute value, and yes, the result is greater than or equal to 3. So case 2 is going to be like this. Thumbs pointed out, and we're shading all the numbers that are outside the middle area. The way we can get to that is, algebraically, is we're going to replace the absolute value of x with plus or minus x. Plus or minus x, there's two versions. There's the positive version, x is greater than or equal to 3, and then there's the negative version, negative x is greater than or equal to 3. Getting rid of the negative symbol, you got to multiply both sides by a negative number, that's negative 1, and then it becomes x is less than or equal to negative 3. So this part right here graphs like this very nicely, and this part over here graphs this also very nicely. I want you to figure out what's underneath that red dot. Notice, although case 1 rejoins into a single inequality, like compound inequality like this, case 2 does not. So let's see what this looks like with more complicated versions. All right, so we've got this over here. Holy moly, there's a lot going on. That's just frightening to look at. It's okay. We're going to take care of the stuff on the outside. The operations that are outside the absolute value would be the minus 5. So let's add 5 to both sides. All right, so we're looking at this, and just it's between these two, the symbol is pointing in this way, like case 1. It's really important to recognize that means we're going to have case 1 with the thumbs touching, and we're going to have 2 values, and then we're going to shade everything in between. Now that we've taken care of the outside operations, let's take care of the absolute value, replace it with plus or minus. Here is the minus version, and you can see minus 4x. We're going to distribute the minus 4x, the negative, to the 4x and the minus 8 to get negative 4x and plus 8. And then when we solve that, we're going to add 8 to both sides to get 24. No, we're going to subtract 8 from both sides to get 8, and then divide both sides by negative 4, and you get negative 2, flipping the symbol. The positive version is going to look like this. I wish I had the arrows. Maybe that would be a better way to structure it, but that's okay. This is going to be the positive version and the negative version. Negative version is here, and the positive version is here. We're going to add 8 to both sides, and then divide by 4, and you get 6. So this statement, that x is greater than negative 2 and x is less than 6, they rejoin together as all the numbers that are in between negative 2 and 6, not including those. And so you can see this is what the number line would look like. Let's do that again. So here we've got operations on the outside and operations on the inside of the absolute value. Let's take care of the outside ones first. Between division and addition, we're going to undo the addition first. What's the undo plus 5 with minus 5. And then undo divide by 2 by multiplying by 2. Absolute value of 6x plus 3 is greater than or equal to 18. And it's going to look like case 2 because of the direction of the symbol. Absolute value greater than symbol number. Absolute value greater than symbol number. It's not case 1. That would be flipped in the other direction. So this is going to be case 2. We're going to break it up into 2 different inequalities. They're going to graph like this, and they ain't never going to rejoin. So we're going to do the negative version. It's negative 6x plus 3. And when we solve it, when we distribute, it looks like this. Undo the subtraction, undo the multiplication, and we get this boundary point. We're going to have a closed dot on negative 3.5. That was the negative version, negative, and now let's do the positive version. Undo the addition, and undo the multiplication, and you get a boundary point on 2.5. So when you graph it all, it looks like this. They're both solid because of the or equal to line underneath both. And we're going in opposite directions. 2.5 is here and moving up, and negative 3.5 is here going down. Wow, there's a lot going on. Let's do this for one more, and then we'll call it a day and practice more in class tomorrow. But before I do, I wanted to let you know for the audio check what profession my wife is. I'm super proud of her. She's really great at what she does. She is a hospice chaplain. She has end-of-life conversations with people who have decided that they are beyond medical care. It is quite. She's really good at what she does, and I'll talk about it more in class if you like. All right, let's take a look at this one here. That's your audio check. Let's undo the addition. Let's undo the outside operations first. We have to undo the plus 7 and undo the times negative 8. So we subtract 7 from both sides, and then we divide both sides by negative 8. Dividing both sides by a negative number turns into this. Now, check this out. If we try and ask ourselves what case it is too early, like if we had started here and said, hey, is this going to be case 1 or case 2? It might look, just by the way the symbol is, that it's case 2. But actually, in fact, because we divided by a negative symbol, it flipped. And so therefore, we're really on case 1. Because there's no more outside operations, we can see its absolute value of something is less than or equal to, and the number over here. All right, so because it is case 1, we're going to expect that it's going to be thumbs touching, boundary point, shade everything in between. Let's confirm that. We're going to replace the absolute value with plus or minus, And here's the negative version. Negative of x plus 14 is less than or equal to 3. Distribute, solve. Notice we're going to flip the sign back again because after we add 14, we have to multiply or divide by -1. And then we get x is greater than or equal to -17. That's going to be one boundary point. The other one we get from considering the positive version. Positive x plus 14 is less than or equal to 3. We're getting that from up here. That's the positive version. I'm going to subtract 14, and then I'm going to combine these two together. X is greater than or equal to -17 is represented over here, and x is less than or equal to -11 is over here. Joining them together, we get something like this. Thanks, y'all. It's been real, and I'll see you in class. Take care.